Hello, everybody. Welcome to our latest webinar, Innovations in Paper Packaging. My name is Paul Jenkins, and I'm Managing Director of UK Packaging Innovation Consultancy, ThePackHub. And what we're going to be covering today, well, some of you may not know about the ThePackHub, so we'll spend a couple of minutes talking about our Innovation Zone and Patent Zone platforms. We then will split the paper packaging innovations that we'll be talking about today into two sections. So there'll be a part one, and then I'm delighted to introduce Aaron Guan, CEO of Neptune Nanotechnologies. He's got some really exciting nanotechnology solutions to enhance the performance of everyday materials, obviously including packaging. So much looking forward to hearing more from Aaron in a moment. And then we'll switch back into paper packaging innovations part two. We'll then spend 10 minutes having a Q&A where opportunities to ask as many questions as you like to Aaron about Neptune Nanotechnologies capabilities. So without further ado, so we've got the ThePackHub has been monitoring the packaging innovation landscape for the best part of 10 years now. And we've created an innovation zone platform called the Innovation Zone. We've actually got about 9,700 innovations loaded there now. It's increased 33 new initiatives every week. And we will be hitting 10,000 packaging innovations in May. And I've got more to tell you about that in a moment. So we continue to invest our time and effort into finding more innovations. So in 2025, we'll have loaded more innovations than ever before, so nearly 1,600. We've also recently launched a patent zone platform, and I've got 3 or 4 examples to show you from that database in a moment. So this is similar to Innovation Zone, but obviously tracks the latest interesting packaging patent initiatives. Now, I mentioned about 10,000 innovations loaded in May. Well, that we thought we would celebrate that landmark with our own exhibit. So Packaging 10,000 will be on in June, 12th of June in Shoreditch in London. This unique event will be a great opportunity to browse hundreds of packaging innovations from around the world from the last 10 years. We will be opportunity to connect with 200 plus industry packaging professionals. We'll also be revealing the decade of packaging innovation finalists. So we're actually, of the 10,000 innovations on the platform, we're going to be having a voting platform where there's an opportunity for everyone to vote on their favorite packaging of the last 10 years. So a really exciting event. We're really looking forward to it. So hopefully you can attend. So that's on the evening of Thursday, the 12th of June. Okay, right, let's look at some packaging innovations. So as you know, if you're familiar to our innovation webinars, we have sort of summarized the latest sort of sustainable packaging trends into 5 sections: recycling, biopackaging, refill and reuse, reduction, and of course, paperisation. Paperisation has been a big packaging trend area for the last few years, really, where lots of businesses are moving out of plastic and other materials into paper-based solutions. I think it's also fair to say that paper is a quite consumer-friendly material and is certainly seen in a more positive light than materials like plastic. So we're seeing lots and lots of change in the market. So what I'm going to do now is talk about some of those changes that we've collated in the last 2 or 3 weeks in our Innovation Zone platform. So the first one is Kohler Paper, and who are very big players in this space. They've introduced a number of different paper-based solutions for products like, in this case, pasta. So this is Astrabio, and they're offering a recyclable packaging alternative for organic pasta. The collaboration introduces the use of Kohler's Next Plus Seal Pure, a heat sealable paper, for the first time in pasta packaging. This paper, which maximizes shelf life and protects the product, is both strong and suitable for standard packing machines. The packaging's environmental benefits include a claimed significantly reduced carbon footprint compared to traditional plastic packaging, as well as recyclability, which contributes to conserving valuable resources. The move aligns with the sustainable values of the Iris Bio brand, as you can see there. And apparently early customer feedback has been positive so far. Next up, we go to the UK, and James Cropper has collaborated with Bruichladdich Distillery to develop a recyclable molded pulp bottle wrap for its luxury redefined whiskey range. This innovation replaces traditional tin packaging with a lightweight, fiber-based solution that incorporates intricate design details such as embossing and debossing, as you can see in the picture. The wrap is glue-free, featuring a single clasp for secure closure, allowing it to be fully recyclable in household streams in the UK. The packaging, designed in collaboration with design agency Thirst, includes a goal to phase out tin packaging through Bruichladdich One Tin Lighter initiative. They claim that while tin is recyclable, its production and transportation emissions have raised sustainability concerns. So the new molded pulp alternative offers a balance between reducing environmental impact and maintaining a premium aesthetic that reflects the craftsmanship of the whiskey. So it's definitely a standout bottle compared to what you might see on a supermarket shelf with conventional tin outer packaging. Next up, Mondi, very familiar to the pages of the Innovation Zone and the Patent Zone, and they've partnered with Perfumia to introduce paper-based stand-up pouches for dishwasher tabs in the Spain and Portugal markets, replacing the previous plastic solution. The new pouches are made using Mondi's recycle functional barrier paper solution with over 85% paper content, making them suitable for disposal in those local paper recycling streams. Mondi's internal product impact assessment suggests that the new solution significantly reduces CO2 emissions compared to plastic alternatives. Next up is Nepal Verpacken, and they received the German Packaging Award for this solution in the sustainability category for its development of a cushioning paper net designed to replace foam padding in transport and shipping packaging. This innovation provides an alternative to PE foams, addressing the challenge of creating a paper-based material with comparable shock absorption properties. Known as the paper mesh, the cushioning solution demonstrates similar restoring forces to PE foam, allowing it to withstand multiple impacts. It has successfully passed standardized drop tests, including those under DIN 22248, providing its effectiveness in providing transported goods. The paper net can be customized in terms of quality and thickness to suit different product geometries and weights. Next up is a paper packaging solution in the confectionery market, chocolate market, from M&S. And we've seen several of these, mainly in Europe and Australasia. And they're trialing a paper-based packaging for their vanilla fudge bar, aimed to eliminate 1.4 million plastic units from M&S's food halls over the next year. If successful, the initiative could extend to other chocolate bars, removing an additional 5 million units. The paper-based packaging is designed to be easily recycled through curbside collection and on-the-go waste systems. The move follows M&S's recent transition to cardboard packaging for its avocado packs, which was also featured in our Innovation Zone. Pot packaging in the Netherlands is leading the way in sustainable packaging with the introduction of 100% fiber closure, a natural fiber-based packaging solution. This innovative closure is designed to integrate seamlessly with recyclable and recycled containers, not just for paper packs, but also for glass and recycled PET and bio-based PE jars. It offers a fully sustainable solution for packaging products like vitamins and supplements, addressing the growing demand for sustainable packaging options. Now we're going to pivot to some patents from the ThePackHub's patent zone. So this is from Nestle, and they've developed or created a new recyclable bag-in-box packaging that focuses on reducing plastic content whilst and improving end-of-life recyclability. The design integrates a cardboard outer box and an inner cellulose based bag that incorporates oxygen and moisture barrier properties. The bag is securely affixed inside the box with adhesive and a reclosable lid for user convenience. Constructed with a multi-layer structure, the inner bag consists of an outer cellulose layer and an inner barrier layer, which may include metallized coatings or polymer films. So that's obviously to enhance product protection, but doesn't deliver a 100% paper-based solution. Overall, the packaging is composed of around 70 to 95% cellulose fiber by weight, making it largely fiber-based and potentially suitable for paper recycling streams. So obviously with patents, they're not fully formed and fully developed. So there is possibly some further work to make this more recyclable, but is an alternative to traditional bag-in-box packaging, which obviously is fundamentally a multi-material solution. Next up is a newly developed single-piece paper-based drink lid that has been introduced as a sustainable alternative to traditional plastic and composite beverage closures. The innovation features a detailed structural design, including a central portion, a nesting lug that fits snugly around the annular rim of a paper container, supporting shoulder, and a dual-walled skirt system. In addition to the sealing functionality, the design includes a stackable feature due to its integrated skirt structure, which allows for easy storage and handling, particularly beneficial for food service and takeaway operations. Last up, before we hear from Aaron, is a newly developed paper container and drink lid design which offers a blend of sustainable material use and functional improvements aimed at the beverage packaging sector. The container features a cylindrical side sheet made from a base sheet layered with an inner coating. The construction includes a clearly defined inner joining line where the ends of the sheet meet on the inside, as well as an outer exposure line on the outside. To strengthen this joint, the design incorporates an additional outer joining line created by folding and securing the exposure line. The bottom component of the container, also made from a polyethylene resin, includes a bottom plate with a folded edge adhered to the side sheet and a distinctive cross protruding line. These developments aim to balance sustainability with practicality, offering viable options for single-use packaging whilst trying to maintain user convenience and performance. Right, so next I'm delighted to introduce you to Aaron Guan of Neptune Nanotechnologies, and they're pioneering advanced nanotechnology solutions to enhance the performance of everyday materials. Their flagship innovation harnesses the power of nanostructuring to significantly improve the strength, the durability, and sustainability of materials used across industries such as textiles and electronics, but more specifically for our interest, packaging. So if you could share your screen, Aaron, welcome to our webinar.
Thank you so much for the kind introduction, Paul. Let me share my screen. Just making sure everyone can see my screen. And
perfect. That looks
perfect. Thank you. Thank you so much.
Over to you.
Will do. So again, thank you so much for the kind introduction, Paul, and thank you everyone for joining me here today. My name is, of course, Aaron Guan. I'm the founder and CEO of Neptune Nanotechnologies. And at Neptune, what we're doing is we're turning organic fishing waste, such as crab, shrimp, and lobster shells, and we're turning them into a powerful bio-based and biodegradable nanomaterial that can really solve a lot of the performance and sustainability challenges in the packaging industry. Now, I want to kick off this conversation by stating something that's perhaps a little bit obvious. Globally, we're observing two megatrends, as we can see. One important trend is obviously the ongoing innovation for high-performance materials to suit our ever-increasing needs for improved products and, of course, improved packaging. And the second megatrend is obviously sustainability. So anyone who have really dealt with new material development in the past decade or so, they will tell you that balancing both the performance aspect and the sustainability aspect into the same material is actually a very, very difficult task. So things like performance, safety, zero toxicity, sustainability. These are all really necessary features for the material of the future. But it is exceedingly difficult to find a material that's on the market today that can satisfy all of these conditions. But at Neptune, we think we have found the answer. Now, quickly, show of hands, I wonder, does anybody really think about the crab legs that you have at dinner and wonder why the crab legs are so strong? Well, we certainly do here at Neptune, and the answer is actually quite simply, there exist tiny nanoscopic crystals that naturally exist and that's buried deep within the shell structure. These crystals, they're called chitin nanocrystals. They're 10,000 times smaller than the width of human hair, and yet they are stronger than steel, they're lighter than plastic, and of course, they're fully biodegradable. So in isolation, these crystals, they really hit every basic benchmark that we really think about when satisfying our continued desire for performance and sustainability. So it seems like the perfect material, but digging these tiny nanoscopic crystals out of these waste crab, shrimp, and lobster shells is actually an exceedingly challenging task. And the reason that it's particularly challenging is if you really think about what makes the structure of the shells. Let's take a crab shell, for example. There are three major components to the shell structure. There is the protein layer, there's a calcium carbonate layer, and then there's a layer called chitin, which is a naturally existing biopolymer. And these three, they all intertwine to really form a sandwich structure. So how do we actually go from shells to chitin nanocrystal? Well, the first step is we really need to isolate the chitin portion away from the proteins and the calcium deposits. This is actually not too difficult to do because the chemistry of chitin is very, very different from the likes of protein and calcium. So extracting chitin from the shell structure is actually relatively easily achievable. But going from chitin to chitin nanocrystal, that is a whole different story. So these chitin nanocrystal, they're embedded deeply within the chitin structure. And as you can probably tell by the name, chitin and chitin nanocrystal, they have an identical chemistry. And there's no simple chemical way of identifying and isolating them from each other. And you cannot do it through a mechanical means either. Sure, there are mechanical processing techniques that can actually grind the chitin down into a nanoscopic powder, but it's just a nanoparticle. It cannot distinguish and isolate or preserve the crystal structure. And as you are suspecting, the crystal structure is really the key to all of this performance. So the fun analogy that we'd like to use to illustrate the difficulty of isolating chitin nanocrystals from chitin is that it's almost like finding needles in a haystack, except that the needles that we're trying to find, they're also made from hay. So our secret sauce is that we have actually found a way to do this. And this makes Neptune Nanotechnologies the first company globally that can extract chitin nanocrystals from bulk chitin structure at scale. Now that we have isolated this nanocrystal, this really leaves us thinking, right? It's a great material, but what can we do with this? And since the topic of conversation today is all about packaging, especially paper packaging, we of course tried adding the nanocrystals to paper. Now, of course, as Paul just mentioned, there is this whole paperization trend. The rise of paper packaging is on the rise. It's seen as a much more sustainable material. So it's gaining a lot of traction. But of course, there's on the flip side, there's a lot of pain points to paper as well. We obviously know that paper is a good material from a biodegradation perspective, but they're also relatively weak. They rip easily, they get soggy when wet, and I'm sure an example like a soggy paper straw, for example, is a problem that is super relatable to everyone. So imagine that if we can just add a couple of percent of our nanocrystals and add it directly into paper, not only can we double its strength, we can also make it significantly more resistant to water and oil and make it 10,000 times more antibacterial as well. And also we can do this, making it non-flammable as well. Flame retardancy is another property. And we're doing all these property enhancements by introducing a fully biodegradable material which of course causes no trouble on the recyclability and the biodegradation. Of course, paper packaging is a big market. We have things like food containers, paper wraps, molded fiber products, bags, etc. And chitin nanocrystal, they're compatible with almost all of them. And by adding chitin nanocrystal to paper, it's actually a very easy process as well. As this nanomaterial, they actually take on a form of a colloidal suspension dispersed in water. So it's a water-based solution that can be easily directly mixed into the pulp formation tank, for example. So of course, I'm making a lot of claims, but of course I cannot make these claims without backing up with facts and data. So for this, we partnered up with a top tier university here in Canada, they're the University of Waterloo, and we really dug into the fundamentals of the mechanisms that's between chitin nanocrystal and the cellulose fibers that's within the paper packaging that you see in everyday life. So in the following few slides, I will be presenting some data. It will be coming from our upcoming publication, which is already submitted for peer review. So first thing, I want to quickly bring up that there's actually natural compatibility between chitin and cellulose. Now, as everyone is perhaps aware, cellulose, they're classified as a polysaccharide. And guess what else is a polysaccharide? Yes, it is chitin. So there's actually some naturally existing hydrogen bonding opportunities, natural synergies between chitin and cellulose. And here is a SEM image that we took and really look at the dispersion and the deposits of these individual chitin nanocrystals, and they're deposited on a single strand of cellulose fiber. So this image here is quite zoomed in, as you can see by the 200 nanometer scale bar. And we're clearly seeing the individually dispersed chitin nanocrystal within the structure. So we see good dispersion, which is challenging typically for nanomaterials, and we have good natural compatibility. So how does this really translate into performance? Again, we are doing some research with the University of Waterloo's lab right now, and we started off by using a very standard handsheet making process, strictly following the TAPI standard. What we did is quite simple. We blended our chitin nanocrystal slurries alongside, and we mixed it up in a big wet pulp mixing tank, mixing them up at a predetermined ratio, agitated them for a period of time through simple mechanical agitation, and we allowed it some time for the dispersion and the bonding to occur. And then we sucked it up, formed the paper, and pressed the handsheets to dry. So a very simple, standardized process. And here are some of the tensile strength results. Here it's normalized by density. And the gray bar here that you can see here is really the control specimen, which is a grade of unbleached softwood paper pulp without any modification. And then the different shades of blues are really specimens containing various loading levels of chitin nanocrystal, anywhere between 1.5 to 5%. So as you can see, there's actually a very large uplift of nearly 100% in tensile strength at the 2.5% loading levels. While a little bit of the diminishing return has occurred at the 5% loading level, the uplift in tensile strength properties is still very significant. Here, I want to make a small quick note that the local optimal that we're observing here is specific to the nature of the pulp, and in this case, it's an unbleached softwood pulp, and it needs to be adjusted for various different factors, such as bleached and unbleached, cellulose versus lignin content in the paper. But in general, you can get away with less loading levels when the pulp is unbleached versus bleached. But as you can see over the next few slides, even in bleached paper pulp, the performance of nanocrystal works still quite well. So here we did quite a bit more testing, further testing, and this time it is in the bleached softwood pulp. And as you can see, this time we needed to bump up the chitin loading level a little bit higher to the 5% level. And then we tested for things like tensile strength, tensile stiffness, elongation and break, and tensile energy absorption. And as you can see, we see a very significant uplift in all of these categories, particularly in strength and stiffness, where the uplift is actually greater than 70%. So here is what gets more interesting. Now, usually when we increase the strength and stiffness of something by adding an additive or a filler, the material will actually end up being a little bit more brittle. So toughness metrics such as elongation and energy absorption, they tend to really suffer. However, this was actually not the case with chitin nanocrystal. We saw a almost 20% uplift in elongation and also a greater than 50% uplift in tensile energy absorption. So this actually makes chitin nanocrystal a really unique additive that improves the performance and the physical and mechanical performance of the paper in an all-round fashion. So as I mentioned earlier, we're publishing a journal paper on this, and we have already published some of these detailed data at the Canadian Royal Chemistry Society's conference last year. So if you really want to dig into the technical data, want to dig into our methodologies, please reach out to us. I'll be happy to send you a copy. Now, the previous few slides, it's all about chitin nanocrystal as a direct in-pulp additive. But we also know that chitin nanocrystal have a really nice self-assembling and film-forming behavior type of property. So if you're able to get them to bond to the paper substrate and have them self-assemble on top into a film, we should be able to get a nice barrier layer to form when you apply them as a coating. So in theory, not only would this layer be able to resist water and oil penetration, it will also be fully biodegradable as well. So September last year, a little bit while back, we built some early coating prototype and we put our theories to the test. So what we did was quite simple. We diluted our chitin nanocrystal concentrate, which, if you recall, is in a water-based slurry, and we diluted down with further water to the point that it has good flow characteristics to be used as a coating application. And in this case, it was about 3.5% by weight. And then we simply dip coated a few of the molded fiber trays that you can easily buy at your local coffee shop. And what we did is quite simple. We dip coated them. We simply allowed them to dry. It does not require a specialized curing process at all. It's quite simply drying and evaporation. And then we proceeded to test some of their water and oil resistance. So as you may know, a typical molded fiber tray, they're made from recycled fiber. So they have large fiber size, they have large pore size, and because they're molded fiber, right, typically they're not treated with sizing agents, no other chemical modifiers involved. So in their naturally existing form, they are highly susceptible to water and oil. So it will typically instantly absorb all the liquid and the whole tray will turn into mush, as you can probably imagine. But once the chitin nanocrystal, the coating is applied, it was able to resist water and oil penetration for multiple hours. And we captured all of our testing on video, which is embedded as a link here, but it's also live on our YouTube channel as well. So feel free to come check it out and don't forget to hit the like button. Now, that was a quick demo. The dilution of nanocrystal as a slurry, that was just a coating prototype. We have taken really the time and we have been further developing this into a ready-made and easy to apply coating formulation. And we have already arrived at a few commercial spec candidates, and we're partnering up here with the National Research Council in Canada, and they're conducting some testing as we speak. So of course, I can't release too much data just yet, but I can definitely give everyone a quick sneak peek. Now, as they say, right, pictures worth 1,000 words. And as you can see here, a typical craft paper, untreated, naturally existing, unformed, once it's coated with our chitin nanocrystal, it was able to withstand water penetration for more than an hour and a half. And the droplet of water, if you really zoom in and see, they're still perfectly beaded, and there's no signs of any absorption or penetration. Now, if you think properties like strength, resistance to water and oil, if you think that's really just the limit to chitin nanocrystal's abilities, well, there's actually more. Did you know that chitin nanocrystal is also antimicrobial as well? So in a recent study, again, that we did with the University of Waterloo, chitin nanocrystal, they showed an antimicrobial efficacy against E. coli of 99.999999%, which is a 9-log reduction per count. And in the post-COVID world, antimicrobial packaging is definitely a very attractive feature. But really, beyond just strength, beyond just barrier, beyond bacterial resistance, did you also know that chitin nanocrystal, they act as a flame retardant as well? And the reason that chitin nanocrystal is flame retardant is because it creates char formation on, and also the surface chemistry of chitin also allow the release of nitrogen, which is essentially suffocating the fire. And this works both as an in-pulp additive and as a surface coating as well. Here, I'm embedding quite a few of the test videos that we did, but again, it's up and live on our YouTube channel, so please come by and check out these testing in action. So as a quick summary, we see a lot of potential of chitin nanocrystal for paper packaging applications, both as an in-pulp additive and as a coating. We see advantages in strength, we see it in toughness, we see it in barrier, antibacterial activities, as well as flame retardancy. But most importantly, chitin nanocrystal, it is a naturally existing material that was simply processed into a nanocrystal form. So of course, this is fully sustainable as well. And beyond just paper packaging, chitin nanocrystal then works for plastic packaging as well. In fact, as of right now, we're actually developing a fully biodegradable thermoplastic film packaging. It's based on thermoplastic starch and it's enhanced with chitin nanocrystals. We're already observing large uplifting strength as well as barrier properties. So we're already seeing some really good lab scale results due to again, a natural compatibility between chitin and starch. And we're already observing the starch properties, the tensile strength more than double thanks to the addition of chitin nanocrystals. And this goes for barrier properties as well. We see moisture barrier properties improve by over 400% in another study that we have recently published. So these lab results have also been so encouraging that we are already engaged with a commercial partner and we're already scaling for pilot production as we speak. And going a little bit beyond packaging, chitin nanocrystal, they actually can serve a wide variety of other applications as well, such as plastics, composites, and epoxies, and they, of course, they also drive a very similar set of value proposition of better strength, better performance, and better sustainability. And there's lots more data that we can share if those applications pique your interest. So please just drop us a line. And moving on to our team quickly, and here's the team that's making it all happen. My name is Aaron Guan. I'm a two-time entrepreneur, an inventor with 9 patents, and a Forbes 30 under 30 list maker. And Dr. Kuo is our lead scientist, who's a former Dow Chemical senior scientist with almost 2 decades of R&D experience. Spencer, our business development lead, is also a serial entrepreneur in the sustainability space with several successful past exits. So while we are still a startup that's barely even 2 years old, we have certainly accomplished quite a bit in the past, and we're certainly very serious about our technology, and we have definitely built a strong and agile team to get things done. So I hope this was an informative overview on what chitin nanocrystal is and what Neptune Nanotechnology is all about. Obviously, we have limited time to dive into all of the details, so we're certainly happy to answer any questions, and of course, happy to schedule more in-depth and private conversations at a later date. And one thing I want to quickly stress here is that everything that you see here, the chitin nanocrystal, it's not just a lab scale exercise. In fact, we're already in pilot production, we're sampling to customers every day, and we're already working with almost 2,000 Fortune 500 companies in the space, and we want to work with you as well. Thank you so much.
Thank you very much, Aaron. That was perfectly timed, absolutely spot on. Well done. Thank you very much. We've got lots of questions, so if you've got anyone in the audience, if you've got any more questions, please put them in the Q&A section and we'll try and answer as many as we can in about 10 minutes. So I'm now going to share my screen and we'll, Aaron, can you confirm that you can see my screen?
Yes, I can.
Yeah, perfect. Thank you very much. Okay, and we'll be back to talk, be Q&A in about 10 minutes. Okay, so let's look at some more packaging innovations that have been recently established and launched. So this one is recycled clothing fiber, which is being used to strengthen paper packaging. So researchers at Austria's Graz University of Technology have developed a method to strengthen packaging paper by incorporating recycled cotton clothing fibers. The process involves shredding discarded cotton textiles and treating them in a water-based solvent solution before milling, ensuring the fibers remain separate and do not form knots. The resulting fibrous slurry is added to recycled paper pulp, significantly increasing the strength of the final packaging material. Lab tests indicate that packaging paper containing 30% textile fibers is stronger than conventional recycled paper alternatives due to the longer cotton fibers, which average 1.7 mil in length. Huhtamaki has introduced a recyclable single-coated paper cup designed for yogurt and dairy products, aimed to reduce yet again plastic content whilst maintaining functionality. The Pro Dairy packaging solution, produced in Europe, contains less than 10% plastic and features a seal and lid that fit the flat rim to preserve freshness. So quite a lot of the innovations we're seeing are moving towards paper-based solutions, but they're still incorporating an element of plastic, obviously, to achieve that barrier. Not all time, that we are seeing organic barriers coming to market as well. But in this case, there is a plastic lining to achieve that barrier. The Finland-based company uses paperboard derived from sustainably managed forests with a focus on maintaining barrier properties, obviously essential to the specific needs for dairy storage. We're seeing a lot of plastic reduction in consumer goods and electronic goods and things like that. So Energizer, which is a global battery and lighting manufacturer, has introduced a fully recyclable, plastic-free packaging solution for its battery range, set to launch initially in the US. The new paper-based design aims to improve both consumer convenience and retail efficiency whilst addressing their sustainability concerns. The packaging features an easy-to-peel opening mechanism and compact storage boxes for consumer ease. Retailers will benefit from a slim profile design that increases shelf capacity, shelf-ready display trays that reduce restocking time and improve merchandising visibility. So there's a wholesale change, not just switching out of plastic into paper, but also delivering some supply chain efficiencies there as well. 5am, so we're all the way over to Australia now for an organic yogurt brand called 5am, and they've launched paper-based tubs for their yogurt range, making it the first brand in the segment to do so. The new tubs and lids are composed of 90% paperboard with a thin PE plastic lining to preserve product quality. This shift is expected to eliminate over 100 tons of virgin plastic from the brand's packaging annually. The transition to paper-based packaging is claimed to make a breakthrough for the dairy industry, particularly for a liquid product like yogurt. Research and development were required, obviously, to adapt the packaging. Modifications were also made to the filling equipment. The tubs are sealed with aluminium foil to ensure freshness, and a paper-based overcap is used. We're flying from Australia to Brazil, and this is N Group, and they've developed the L8 cup, a paper cup with an integrated lid designed to reduce the use of plastic lids. Available in 3 sizes, 100ml, 150ml, and 300ml. The cup is intended for various beverage and food items, including drive-through and delivery applications. The design allows for easy closure with a simple finger press and conveniently accommodates a paper straw. The L8 cup is recyclable and biodegradable, breaking down, it is claimed, within months when disposed of in regular waste. That is produced using standard paper cup manufacturing equipment, making it scalable and accessible for global licensing. We're flying from Brazil to South Korea, and this is a paper-based container that integrates braille and product information on the exterior using a novel foaming technology. Unlike traditional braille embossing methods that rely on pressure, this approach utilizes a specialized printing process that modifies color without requiring additional post-processing. This method allows for clear braille markings whilst maintaining cost-effective production within existing manufacturing processes. Now, the innovation zone has probably tracked 25, 30 Braille type initiatives over the last 18 months to 2 years. So an interesting way to improve pack accessibility. Um, and a stat that I read recently is that um, not that many partially sighted and blind people can actually read Braille. It's something like 17%. So maybe that's one reason why we're not seeing a wholesale switch to this type of packaging. So we're going from South Korea to France, a real trip around the world, get the air miles in. So this is Gay and Papier, a coating specialist from France, combined with LFI Emballage, a packaging company also based in France. And they've partnered to launch a cardboard yogurt pot. We seem to be doing a lot of yogurt pots this time around. The plastic-free recyclable packaging serves as an alternative to traditional plastic yogurt containers. I think it's fair to say the plastic yogurt container shelf life is limited. We're moving significantly into paper-based solutions here. Made from a specific type of cardboard called Universal B VS 270G. It's a mono material coated with a water-based adhesive for heat sealing. The pot offers a barrier against water and fat, ensuring compliance with food safety standards and effective product preservation. The last innovation before we go over to ask Aaron some excellent questions. So this is Antigua and Standridge Color Corporation, and they partnered to develop a water-based coating board for single-use food packaging, offering an alternative to PE-coated paperboard. With increasing sustainability commitments across industries, this collaboration is responding to demands for recyclable and fiber-based packaging. The company designs and produces its coating equipment in-house, allowing for tailored solutions. The PE coatings provide barrier protection for food packaging, but pose recycling challenges, as we all know, as they hinder fiber recovery. So the water-based coatings offer a viable alternative, allowing for improved recyclability whilst maintaining the necessary performance characteristics for food service applications. Okay, so they're the innovations. Let's pivot back over and look at some of the questions we got for the Neptune Nanotechnologies presentation. I'm going to stop sharing my screen. If I Hi, Aaron, are you there?
I am here.
Okay,
Seems like my camera's gone a little bit iffy. Just
okay, right.
Hmm.
Doesn't matter. The camera will come to light. Come to life, I'm sure. So we've got so many questions. Let's fire through these. So the first one, in terms of the chitin material, how can you maintain the sustainable harvest? And if demand is high in the future, how can you make sure that production can meet demand?
That is a fantastic question. So, one really good thing that we have to iterate here is we're not harvesting these crustaceans for material.
Mhm.
These are strictly coming from a byproduct from the fishing industry. And I'm sure you've seen the canned foods of the prawns and lobster tails, right? So a vast majority of these shells, they're actually shipped back into the ocean and they're really dumped in. So there is an 8 million ton a year supply of that we can harvest from a very, very sustainable way. And the
Okay.
second aspect I want to quickly mention is we are an additive or we are a very thin coating. So we make up a single digit percentage, small single digit percentage of the overall packaging. So we are not going to be shipping multi-million ton volumes, even though we are in a big market like this. So really coming from the sustainable supply of 8 million tons a year versus the small amount of volume that we actually need to power a lot of these products, we are certainly okay here.
Okay. Brilliant. Brilliant answers. Um, Question about allergens. Have you tested against allergens, and would this be a worry if used on food packaging?
This is not a worry at all, but I have to put a little asterisk. So a lot of the allergies that we know about, particularly the seafood allergies, I'm sure that's a concern, is driven by the protein. So it's a seafood protein that's causing an allergenic reaction. So our process is chitin. And not only is it chitin, which is already isolated away from the protein and the calcium deposits, we are a single nanocrystal. So we're really far removed away from chitin, from the proteins. And as a chitin nanocrystal, I have to go back a little bit back, and chitin, it's already actually used as a direct food additive in a lot of the applications. There's actually health publications that actually speaks to the dietary fiber effects of chitin. There's lots of study that we can cite. It is a food safe material. It is food, but the little asterisk I have to quickly mention is because chitin nanocrystal is new, it's still nanoscopic, it's still bonding to the surfaces. We still do have to go through regulatory testing, and we're actively in pursuing that right now. But really, from our fundamental understanding of the material and the properties, we should be quite in the clear.
Okay, perfect. You may have actually answered this question. Dip coating, how much coating did you use?
We have to go back to the prototype. So we diluted our nanocrystal down to about a 3.5% slurry, and we don't have a good way to track the thickness. This is why we're partnering up with the National Research Council of Canada. But from what we see from the demo that we did in the video, the weight uptake is about 1 gram on a 27 gram tray. So if you work back the math, it's about like 3% in coating weight.
Okay, brilliant. A question about capacity. So obviously the paper and cardboard industry is very large. Do you have the capacity to deliver large quantities that will be needed?
The short answer is not yet.
Hmm.
So we are a startup. If you asked us the same question 2 years ago, we would have told you that our capacity is 2 grams a day. Right? We've already scaled 1,000x from that point till now, but we're still a pilot plant. Our capacity as of right now, we're able to serve the sampling demand, some smaller scale pilot trials, and we're actively engaged with customers. But in fact, we're actually raising a fundraising round right now. We will be expanding that production capacity, and we will be scaling to meet demand. So we've already gone through a lot of the scaling trials, and we see our capacity in the future as relatively smooth sailing from a technical perspective.
Excellent. Okay. You mentioned about the excellent antimicrobial properties, which I thought was fascinating. Does the chitin improve other barrier properties such as gas and or moisture?
Gas and moisture, we are doing testing as we speak right now with the National Research Council. So I can't give you a hard data point just yet, but it certainly does, and we can easily see this in our qualitative testing by barrier and moisture testing. We've seen the water droplet that stays perfectly beaded, and chitin. If I were to go back and get into the fundamentals, it's a naturally existing biopolymer. So while it's film forming, it's effectively acting as a plastic liner, except that this plastic liner is fully natural and fully biodegradable. And in a slightly unrelated note, in plastic packaging, we actually did publish a report, a peer-reviewed journal, and it's actually the chitin is added to polypropylene and polyethylene for film packaging, and we saw a 400% uplift in the water vapor transmission rate. So there you go. It works highly as a barrier material from a direct contact perspective and from a gaseous permeation perspective.
Okay, lots of questions about the barrier. I think this is a particular area of interest. So,
Mhm.
related to that, is the application of the barrier on machine or off machine? And another question, which you might be able to answer all in one go, what is the method of application of the additive? Sorry, it's additive, not barrier, actually. So let's focus on the question about whether the barrier is on machine or off machine.
What we are currently doing, so if I were to explain it, perhaps I should brought a better photo, is what we have is it's a water-based coating solution. So it would go on in a very similar fashion to other water-based coating application as well. So what we have tested in the lab is it works for dip coating, it works for roll coating, and it works for spray coating as well. So any wide variety of method, it's coatable. It is a water-based solution, and what is happening is it's not a curing process. Once you drive away the water through simple drying means, the nanocrystal will naturally tend to bond to each other, right? In certain applications, it may consider be agglomeration, but in a coating application, it's a nice film forming property that we see. So yes.
Yeah, okay. I'm not sure. I think this is a different type of question. So what is the method of application of the actual additive? Should it be added in the pulp or as a sort of like a varnish afterwards?
It works both ways,
Yeah,
actually, but it really does depend on what properties you're chasing. So if you really walk back and think about what kind of nanocrystal is, it's a biodegradable but incredibly hard and stiff material. So if you were to deposit this in pulp and as part of the paper matrix, what you get is you get a lot more strength benefit. But if you apply it as a coating after the fact, what you're getting instead is more barrier properties. So really depend on which way do you want to lean to in terms of the performance tuning, but it's viable both ways.
okay, brilliant. We've got a couple of questions around the growth of vegan-based products. I mean, how do you navigate the trend for vegan? Presumably, you can't make any sort of claims in that nature.
Interesting question. And we actually get asked this question a lot. And chitin, while the most obtainable source does come from crustaceans, so animal feedstock. But chitin is also naturally existing in mushrooms at smaller concentrations in harvesting. So it's definitely a viable alternative. But as of right now, what we are focused on, we are a smaller startup,
Yeah.
limited resources. We have to get the easiest possible feedstock to power through our technology. But once we grow a little bit more, and we can certainly diversify our supply, and we can go into plant-based chitin as well.
Okay. So we've covered questions around barrier, around scale, and the other big question that everyone wants to know is about cost. So are you able to sort of differentiate between the traditional additives to yours regarding sort of the cost?
That's a good question. And of course, we're a startup, we're a limited volume, so I cannot give you a very, very exact prediction. So don't quote me on a number, but it is really from our perspective that once we're able to scale, we should be able to get our coating solution down to the price point of about $5 per pound. And this will be quite equivalent to a lot of the packages that's used in the paper industry. So we expect to be cost competitive, quite simply because we have the technology to scale and the feedstock is really widely available. And because it's a nanoscopic material, you have to use actually a very small amount of quantity. So all these factors combined, we should be able to be quite price competitive once we scale.
Okay, brilliant. One last question, because I think I've given you a record number of questions on our webinar. It's probably about 10 or 12, and you've answered everyone brilliantly. There is a lot of interest from nanocellulose, which is also bio-based and
Mhm,
sustainable.
mhm.
How does your chitin nanocrystals compare with nanocrystalline cellulose? That's a very specific question.
That's a very, very good question. And often people that's in the know will find that there's a lot of similarities between chitin and cellulose, right? They're both nanoscale, they're both crystalline structure, and they're both polysaccharides. What really differentiates chitin is, unlike cellulose, which only has hydrogen bonding opportunities, chitin has both hydrogen and nitrogen bonding group as well. So it allows it to bond to a wider variety of possible substrates. That's number one. And number two, chitin nanocrystal, they have much, much better antibacterial properties. And third, they have much better anti-flammable characteristics. And what is also quite interesting in our study that we did is chitin nanocrystal, once you add it to the paper pulp, which, as you know, is cellulose fiber, we actually see performance uplifts higher than equivalent loadings of cellulose nanocrystal. So again, very interesting, very similar in a lot of ways, but in nuanced ways such as interface compatibility, in dispersion, in antimicrobial properties, and in flame retardancy, chitin certainly has an advantage.
Excellent. Well, Aaron, thank you very much. A really informative presentation and Q&A from a man that really knows his subject. So thank you very much for that.
Of course, thank you
Um,
so much, Paul.
Thank you very much. We will be the outputs will be emailed to all registrants by tomorrow, and there will be also an opportunity for you to contact Aaron for a further follow-up call. So we'll be sending out the outputs with a recording tomorrow for your information. Last but not least is to talk about our next webinar, which is how to future-proof your plastic-free packaging, and we'll be joined by the team from Zampler and 2M Group of companies. So that will be on Thursday, the 24th of April. So I guess that's 4 weeks today, same time, 3 o'clock GMT. Although if anyone in the States, our clocks go forward next week, so it'll be slightly different, but it's 3 o'clock UK time. I'd just like to finally thank everybody for their attendance and attention, and thank you very much for supporting our webinars. We had over 400 registrations for this one, so very popular, and look forward to seeing you next month. Thank you.